Hello, guys. So I would like us to look at this question. Use Demoivre's theorem to show that cos 4 theta is equal to 8 cos to power 4 theta minus 8 cos squared theta plus 1. Now, from Demoivre's theorem, we know that if you have a complex number, z is equal to r theta, then when you raise it to the power, you raise this to power n, this is the same as this raised to power n. And you know that a complex number in polar can also be expressed as r cos theta plus j sin theta. So it's the same as you raising this to power n. So all along the value of r does not change. So we are going to consider this. So ideally, when you're told to find the expansion of cos 4 theta, now we will start from here. Cos 4 theta does not exist alone. So we have cos 4 theta plus j sin 4 theta. Now this is the same as cos theta plus j sin theta raised to power 4 according to Demoivre's theorem. In order for us to find this expansion, we're going to expand the whole of this. And since we only want the expansion for cos, we will take the real parts. Now, let's come and evaluate this here using binomial theorem. So that will give me cos raised to power 4 theta plus 4 cos raised to power 3 theta j sin theta plus 4 3 cos squared theta j sin theta squared, all this divided by 2 factorial plus 4 3 2 cos theta j sin theta raised to power 3, all this divided by 3 factorial, and then finally plus 4 3 2 1, cos is now raised to power 0 and that gives 1, so sin theta j sin theta raised to power 4, all this divided by 4 factorial. Then we're going to simplify that expansion. So this is going to give us cos to power 4 theta plus 4j cos cubed theta sin theta, and then 2 factorial cancels with it, you get 2, 2, and this gives us 6. Here we're going to have j squared, and j squared is minus 1. So let me write the minus there. 6 cos squared theta sin squared theta, if you open this up. Then I have 3 factorial here is the same as 6, so it will cancel with 3, 2 here. J cubed is the same as minus j, so we'll have minus j there. Then we have 4, so we have minus 4j, and then cos theta, then sin cubed theta. And finally, the last term, 4 factorial will cancel 4, 3, 2, 1. J raised to power 4 is the same as 1. So I have here sin to power 4 theta. This is sin cubed theta. So in order for me to find the expansion for cos 4 theta, I take the real parts, i.e. the parts without j. So the real part, I have cos 4 theta. Cos 4 theta, this has j, so I take this other one, minus 6 cos squared theta sin squared theta, and then this last part plus sin to power 4 theta. But now in our question, we've been told to show that that expansion is equal to what? As you can see, the question, the answer has cosine terms alone. So I am going to rewrite my answer so that I get rid of all the sine terms. Now we know that cos squared theta plus sin squared theta is equal to 1. So I can be able to rewrite sine terms in terms of cos terms. So I will rewrite this and I will rewrite this. Okay, so this is going to give us cos to power 4 theta minus 6 cos squared theta. Instead of having sin squared theta, I can have 1 minus cos squared theta plus sin to power 4 theta. This is the same as 1 minus cos squared theta squared. Okay, so opening the bracket and then simplifying, this is going to give us cos to power 4 theta minus 6 cos squared theta plus 6 cos to power 4 theta plus opening this bracket. So this will be 1 minus 2 cos squared theta, and then plus cos to power 4 theta. Okay, fine. So putting all these values together, I have cos to power 4 theta, cos to power 4 theta, and this. So that will be 1 plus 6 plus 1. That will be 8 cos to power 4 theta. And then this is cos squared. This is cos squared minus 6 minus 2. That will be minus 8 cos squared theta. And then what else do we have? We have plus 1. And that is what we were told to show. So 8 cos to power 4 theta minus 8 cos squared theta plus 1. That's how we go about that expansion. And just in case you were told to get the expansion for sine to power 4 theta, then we would come back to our expansion here and take the imaginary parts without taking the j, just take the imaginary parts. That is what will give you the expansion for sine to power 4 theta.